sketch the region, recall that we don't care about this function at all. We just care about these bounds of integration and the order of integration. So we're going to start with this outer integral, dy, and it's going from 0 to 3. So when y equals 0, we're down on this axis. That's this limit. When y equals 3, we're up here. That's this limit. And then this limit is x equals 1. That's a 1. And then this other limit is x equals negative y. And so that left us with this nice region in here. Then we extend the problem. We were given the integral using horizontal strips. So starting for a particular value of y, starting at a limit over here and walking to a limit over here. But now I'd like us to reverse the integral and do it using vertical strips, meaning starting at a lower bound and going to an upper bound. At every point in the region, at every point in x from which we're going to make our vertical strip, so there's an x and there's its associated vertical strip, we're stopping at 3, so we know that the upper bound, we're integrating vertically, so dy is on the inside, dx is on the outside. We know they all end at 3, but where do they start? In this green region, they all start at 0. So it's the integral from 0 to 3 of f dy. And what are the x bounds that describe this green region? We're going from, it looks like, from 0 to 1 in x. And so that accounts for all these vertical stripes, but it doesn't account for our whole region. We actually need to use a second integral to manage to account for the whole region. We need to figure out what the heck these vertical stripes are and add that integral to this first one. So here we are sitting at a particular value of x, and we're wondering what the lower bound and upper bound are. Well, the upper bound is still 3, but now the lower bound needs to be a function of x, and we had that this curve is y equals negative x. This is a function of x for that lower bound, so we're ready to put that in. We're integrating from negative x up to 3, and then in y, we're stepping from this point negative x up to 3, and then what are our bounds that we're doing this over in x? We're doing this from, oh gosh, what is this point? Well, this function is 3. This one must be negative 3. So we're going from negative 3 up to 0. Okay, this is our reversed integral. We actually need to do 2 integrals to represent this same region that we were able to represent with just one integral when we used horizontal strips.